Hey everybody, so I had to pause the video and class started, so I'm picking back up. We are finishing up 8.1 and we're starting to look at factoring. And so we did greatest common factor, and now we're going to be looking at factoring when you have three terms. We'll also look at when you factor two terms, but today is three terms. And this mentions something called the grouping method. I have decided we are not going to be using that method. We're going to have, I don't even know what to call it, the intuitive, I know how you spell intuitive method. It's going to go a little bit faster, and I'm hoping it will be a little bit easier for you to do. So what we're going to do is first practice making what I call the X. So that's why you see these big X's on all the pages. And then what we're going to do is we're going to go back and revisit what we talked about in our chapter 7 when we multiplied polynomials. And I'll show you how knowing how to multiply polynomials will help you factor polynomials. So to make the X, first it has to be in standard form. And what you do is you loop the first and the last term and you multiply those together. So 3x squared and negative 5 gives me negative 15x squared. And then this middle term goes in the bottom of my X. So let's practice that over here. Standard form, multiply the first and the last, negative 18x squared, and the middle term goes in the bottom. So let's again try these two. Multiply these, 12x squared, circle that, that goes in the bottom. So all three terms help you make up this X. And then the last set, multiply those. And then the middle goes in the bottom. So that's the first part. The next part to the X is you want factors of 15 that if you multiply them, you want factors of 15 so that when they multiply, they give you the top number, and when they add, they give you the bottom number. So the way we're going to start that, and wish I had a factor table, is you would need all your factors of 15. So these are our factors of 15. So which of these, whether I add or subtract them, I know they're going to get me to this number, but which set would get me to this number? And that would be a 3 and a 5. So when I fill out the sides, I want to put a 3x and a 5x in there. The reason why we're doing this is when I add these, I should get this term, and when I multiply them, I should get this term. So right now when I add these, I get 8x. So what I'll have to do is turn the 5 into a negative. So 3x and negative 5x, you're combining like terms, is negative 2x, and when you multiply these, the 3 and the negative 5 give you negative 15, and the x and x make the x squared. So let's go for 18. Here are my factors of 18. And I would just be looking at which set whether I add or subtract could get me the bottom one. And that's going to be 3 and 6. And again, I'm going to put a 3 and a 6. And it doesn't matter if you put the 3 or the 6 first. That's up to you. Right now, when I add these, I get 9. So to get 3 out of these, I'm going to have to make this 3 become negative. So negative 3x plus 6x is this term. And when you multiply, the negative 3 and the 6 make the negative 18. The x and the x make x squared. So going down to 12, here are my factors of 12. So which set will somehow get me to a negative 7? That would be a 3 and a 4. So again, when I add these, I get 7x. I need negative 7x. So this time I'm going to make both of them negative. So add these terms up, negative 3x, negative 4x, that's negative 7x. When you multiply, negative 3 and negative 4 make 12, x and x make x squared. And the last set, too many factors is 60, so I'm just going to go ahead and tell you that 15 and 4 is the set. And we don't have to change anything to negative because when I add 15x and 4x, I get 19x. When I multiply them, I get 60x squared. So now what we're going to do, now that we've set up our x, is we are ready to find the factors. So again, the form that we are currently working for all of these is standard form. So that's what the SF is saying here, standard form. And we are working to get them in factored form. So what I'm going to do is squish my factors. Remember, factors multiply. You've seen factored form. Inside those parentheses will be one factor, and inside the other will be the other factors. Because again, when you have factors, you know, the only way to have a factor is to have a pair. So 3 can't go without 5, and 5 can't go without 3. So the same thing's going to happen here. I'll have one factor, and where you have one, you have a second. And so I can go through all 4 of these and just go ahead and get my parentheses set up for my factors. So what I want to do is go back to what we talked about, and I'm jumping to chapter 7, and I'm looking on page 25. So here when we talked about this, we actually were starting in factored form to get to standard form. And when you start this out, when we're trying to find the factors, we're asking ourselves, what neighbors in one parentheses and what neighbors in the other parentheses to get this. So let's kind of back up and start a little simple. So I'm going to go back to page 29, but I'm going to take a little time out from there. So let's take a look at something that our answer might look like. And just remind you of the neighbors meet the neighbors. So 2x meets x, and we get 2x squared. 2x meets 1, and I get 2x. 7 meets x, and I get 7x. And remember, I'd stack those like terms. And then 7 meets 1, and we get 7. So when we're done, we have our first leading term of 2x squared, 9x, and 7. So the part I want you to focus on right now is that the first term and the other first term, when these neighbors meet, give us our leading term. All right? And that's how we're going to start this out. What I want to know is what neighbor met what neighbor to make 3x squared. And the more you practice this, the better you will get at it. But that's just going to be a 3x and an x. We're not going to have any crazy fractions, but 3x and x is 3x squared, right? So let's try the next set. What neighbor met what neighbor to make the 2x squared? Because when the first neighbors meet, you always get the leading term. So that would just be a 2x and an x. Not doing anything crazy. Let's go for this one. What neighbor met what neighbor to make this 5x squared? And that could just be 5x and x. And if you do notice, I do tend to put the bigger one first. That's just a habit of mine. You don't have to, though. And then to figure out 3x squared, what neighbor met what neighbor to make 3x squared? Well, that's just 3x and x. All right? So from there, what we're going to do is we're going to draw all our focus to these numbers that we worked so hard on getting. So I'm just going to circle the first 2. And what we're going to do is we're going to make a loop, 3x meeting a neighbor, and then x meeting neighbor. So let's try that over here. 2x meets a neighbor, x meets a neighbor. Going down here, 5x meets a neighbor, x meets a neighbor. 3x meets a neighbor, x meets a neighbor. Because when the neighbors meet, we're going to get this. So here we go. Let's go back up to this one. So what I'm going to ask myself, is it possible for 3x to multiply, distribute, to meet something else to make 3x? And that is possible. Just take it times a positive 1. So from there, I get this 3x. And I'm going to keep track of which one I did. And so this one's been done. Lightly cross it off. So is it possible for x to meet somebody, to multiply, to distribute, to get this term? And that would be a negative 5. And we are done. We have it in factored form. And when we're done, we'll take one of these and we will go back and show how the neighbors meet the neighbors to get this. All right? So let's start with this one. Now we're going to check this. Is it possible that 2x can distribute, meet, multiply to make negative 3x? Not unless it's a fraction, so we won't try that one. Let's try this one. Can I take 2x times something, multiply, distribute, to get to 6x, and that would be positive 3. So 6x is taken care of. And then I'm going to ask myself, can I take x, multiply, distribute, meet, to get negative 3x, and that would be a negative 3. So you can see how both loops get me these numbers. And now you have your neighbors. When 2x minus 3 meets x plus 3, you will get back to this. All right, let's try this one. So again, I'm drawing my focus now on all this work that it took. So can 5x multiply to something and make 15x, and that would be a plus 3. So got that one done. And can take x and multiply to something to make 4x, and that would be a plus 4. So as you can see, we're done. We found our factors. When this neighbor meets this neighbor, we get to this. And our last set. So again, drawing our focus here. Can 3x multiply to something and make negative 3x? Sure, that'd be a negative 1. So got that one. Cross it off. And can x meet something and get the other one? Sure, that would be a negative 4. And so I just keep track of which loop got me which. So we're done. We have factored these. And so again, you have found the neighbors who meet to give you this. So let's go over how that happens. So in pencil, when 3x meets x, that's 3x squared. When 3x meets the minus 1, that's a negative 3x. Now, negative 4 is going to go meet the neighbors, and we get negative 4x. And then negative 4 is going to meet the negative 1, and I get a positive 4. And when I combine my like terms, there you go. So we just practiced going from standard form to factored form. So again, what we're doing is we are finding out who the neighbors were that met to give us the standard form. That's it.